Hello friends. I want to talk about initialization this week. The idea of initialization is that when we initially declare a variable, we want to assign a set value to that variable before it gets used. Now we do this because when we initially declare a variable, when we say integer x, what we're doing is naming a memory location. That memory location may already contain data from a previous program, from a previous execution of something else. Whatever it is, some data or some garbage data may already be in that memory location. So when I say integer x, whatever's in that memory location becomes the value of x. Now, for most of the programs that we have written over the past few weeks, we have used every single variable that is in the program. But last week we ran into a new situation where we began to do those logical evaluations, in the carpet program where the user was able to say, I want to move furniture, I don't want to move furniture, and then there is a new cost associated with that. Or in the taxation program, if under certain conditions there was a certain amount excluded, those variables were declared and may or may not be used in the program. If the user or your program never adds a new value to that, the value of, say, line 9 in your taxation program may contain garbage rather than the value that you're expecting. So the idea or the practice of initialization is done to ensure that you as the programmer know exactly what value is in any variable at any time. And so this process is very simple. When we declare a variable, we say integer x, we're going to add on an assignment statement that fixes the value of x before the program begins to get executed. So for example, we'll say integer x equals 0. Or character A equals blank, string name equals blank, Boolean true, bad example, Boolean move furniture equals false. Whatever the initial value is that we want to fix, we're going to set that up as an initialization statement. So what I'm going to do now is I'm going to write some code for you, and we're going to look at what happens if we don't initialize a variable, what the potential outcome is, and how we fix that by initializing our variables. So let's switch over to the code editor now and have a look at how that works. Alright, so here we are with some very basic code. You see that we have 3 variables, integer x, integer y, integer z, and then all we do with them is execute the program and send to the output stream their values out to the screen. So we're going to execute this, and you see that we get some interesting values here. So 4, 4, 5, 5, 6, 9. So this is just garbage. This just happens to be garbage that's already in the memory location when we execute the program. Now, I want to show you something interesting. We're going to execute the program a second time, and you see that the values have changed from the first time because whatever's going on in the memory location or the new memory location that X, Y, and Z are getting assigned to, we're getting those different values. If you don't initialize your variables and you were to use, say, y or z in an expression, that garbage value would become a part of that expression. So hang on, I'm going to modify this now, and we'll see what happens when we initialize. Okay. You can see that I've modified the code a bit. I have added initialization to each one of the variables. So I've said integer x equals 10, integer y equals 20, and then z equals 30. Now what you would probably do is say integer xyz equals 0 for each of them, so that you establish 0 or an empty variable as your baseline value. Now when we execute this program, what should happen, or I'm sorry, what will happen is that when we display the cout statements, x will equal 10, y will equal 20, and blah, blah, blah. I've also added a little expression, and we can be secure in the results of that expression because the values have been initialized and fixed. And I'll show you what will happen if one of the values is not initialized. So we go and we process this code, we execute it, and we see that x, y, and z equals 10, 20, and 30, and our expression comes out to 230 just as we expected it to. Now I want to show you what happens when something is not initialized. So we're going to come in here and I'm going to take the initialization off of y. So now remember, if I have an uninitialized variable, whatever value is in that memory location is what will get substituted in for y. You remember we had all those odd values the first time we ran the code. So we execute the program, and now look what we get. So x and z remain 10 and 30 because they were initialized, but the value of y is, what is that, 3,260,972, and obviously that has a poor effect on our expression because we will not know what the value will be when we execute the program. So you see the importance of initializing variables. I want to do one more demonstration because right now I'm using every single one of these variables, but I'm going to show you where errors occur when we fail to initialize variables. All right, now we see that I have made a little more extensive modifications to the code. And this is a little more similar to what you did on last week's assignments and what you'll do in your future assignments. And that is that the execution of the program can take different paths depending upon what choice the user makes. So in this case, I'm going to give the user two choices to select either S or T, and then based upon what value they give me from the keyboard, I'm going to collect an additional data value. So kind of similar to, are you going to move furniture from last week? Or the choice that you had to make about evaluating overages in income or interest, student interest deductions. So on a very simple basis, we're doing the same thing here. If the user should choose S, then we will come in and get a new value for the variable Z. If they choose T, then Z is going to be initialized to whatever is in that memory location, because if you'll notice up in the declaration up there, integer Z is not initialized. So we're going to go ahead and execute this program. And you see we have a menu, so we will take the take a chance, which uses the uninitialized Z value. And well, hey, we got pretty lucky because it looks like the value in that memory location was 0 because we're getting 10 times 20 as our return value. But you can't count on that. We got lucky this time, but there's no way that you can count on that for sure. Now, if we execute the program a second time and we choose option S, we're going to be asked for an additional value. So we'll type in 50 and we get 250. So just once more to review, initialization is fixing the value of a variable before you use that variable. And so in normal circumstances, what you would do is say integer x equals 0, integer y equals 20. You'll notice here I have a character variable called choice, and I initialize that to a blank space so that when this menu comes up, when I execute this line right here, choice, it already has a blank value in that character. And so if I don't initialize a variable, if I leave z uninitialized, whatever garbage is in that memory location, that is what will get used in this expression if the user should choose take a chance and skip over this if statement and skip right down to the expression. So it's real important that you initialize your variables. It is a good habit to get into. So if from here on out, I'd like to see in your programs, when you set up variables, whether they're doubles, floating point types, or integers, set them to 0. When they are characters, set them to a blank. You will need to put a space in there because it actually has to have a character value. If you are initializing strings, just put a pair of quotation marks. And if you are initializing Boolean type variables, I generally set mine to false. But if it fits better with the design of your program, set it to true. I hope this has been helpful, and I look forward to seeing any questions that you might have in the discussion.